Welcome to day 1 for Hands-on AI Agents course, where we'll be looking at Introduction to AI Agents and the different tools that we can use. Today, our goal is to first understand AI agents and their use cases. As you know by now, AI agents are very popular, so that means there are many use cases of that. So we're going to cover some of these use cases in today's video. We will learn why Ollama is the best for local AI, and that's the tool that we'll be using for building our local AI agents. Next, we'll look at installing and setting up Ollama. Then, we will learn how to build and run a basic AI agent using LangChain and Ollama. By the end of today, you'll have an AI agent running locally on your machine. So let's get started. Before we jump into any of the hands-on programming, let's understand what are AI agents. AI agents are intelligent systems that can perceive, reason, and act to achieve a goal autonomously. Unlike simple programs, AI agents have decision making capabilities and can perform tasks without human intervention. Now, how are AI agents different from traditional automation? Let's look at a table here. So based on feature and traditional automation and AI agents, let's look at first focus on a feature which is rule based. Traditional automation, yes, it is rule based where you have if else logic. Whereas AI agents, there is no rule based. It uses AI ML to understand, to reason. Next feature handles complex tasks. Traditional automation cannot. AI agents can. Learns over time. Traditional automation doesn't learn, it just is static. AI agents, yes, via memory and feedback loops. And we'll learn a little bit about memory today. Dynamic responses. Traditional automation, nope, doesn't have any dynamic responses. It's predefined. Since it's if else, if something, then display something. For AI agents, yes, it's AI generated. Every time the AI is learning, it's going to give you better answers over time. Let's look at some of the examples of AI agents. So for special agent types like chatbots, the use cases include customer support and personal assistance. For agent type like web scraper agents, they're used for automated research and data extraction from websites. For agent types like task automation bots, the use case for them are auto email responses and calendar scheduling. And then we have multi-agent systems. The use cases for that can be AI CEO or AI employee agents that work together. And we will be looking at implementing all these different types of agent types in this particular course over the next few days. So let's get started. Let's talk about why use Ollama for AI agents. Now, Ollama is a powerful tool, and we'll be looking at how to install it and where to get it from in a few minutes. But why use Ollama? First, it runs AI models locally. There is no API cost and it's completely private. That means everything that you do is on your machine. You don't have to connect to internet, you don't need an internet connection. Once you have the models downloaded locally, whatever you do stays on your machine. It supports open models. We have models like Llama 3, Mistral, Gemma, DeepSeek. All these are available to use in Ollama. It's optimized for LLM inference. There's faster response times than cloud-based APIs as it is running locally. And the LLMs are optimized because of inference. Next, it works offline. As I mentioned, no internet is required after setup. So once you have the entire setup ready, have your models downloaded, you can just go on a cruise ship, be anywhere in the world where there's no internet, and still work with the models. Let's talk about setting up Ollama. Now we have heard so much about Ollama. Let's go ahead and install Ollama on our machine. Now to install Ollama, what you have to do is you can go to the website ollama.com, ollama.com, and in here you'll find an option in the home page itself to download Ollama. So you can go here and you can press download. Now depending on which machine you are, it will probably point you in the right direction, But let's say if you have Mac OS, you can download for Mac OS here, and once it's downloaded, you can follow the prompts. Next, if you want to run it for Linux, you can copy this and run it on your terminal or command prompt on Linux and run that. For Windows, again, you can download for Windows from here and run it, the executable file that you download, the exe file that you download, and follow the steps to install it. Once you install, it's always advised to make sure that you restart your machine just in case if there was some issues or some problems or it needs to set up something. So I've seen a lot of times when you install something and you restart your machine, it will work perfectly fine. So I'm going to go here and open terminal. First thing that you can see is, here I am in my desktop and AI agents is the folder that I've created. But no matter what machine you're running, be it Mac, Windows or Linux, you can go there and say Ollama dash dash version. If it gives you a version, Ollama version 0.5.11 for me, that means Ollama is installed for you. If it doesn't give you a version, that means there's something wrong. So if it says Ollama command not found or some other error, just let me know in the messages and I can help you out installing it. So I have it running, so perfect. Our next step is to look at the models. So now that you have set up Ollama, our next step is to download a model for AI agents. We'll need an AI model to run our AI agents. So let's download Mistral for now. So I'm going to go here, and this is my, again, Ollama website. You can go to models on the top here, right here where it says models, and look at all the different models available. They are by default sorted by popular. You can change it to newest, and this is the new one updated 3 days ago. If I go to popular, it shows DeepSeek R1, which is updated 2 weeks ago. You can look at embedding models, vision models, tool models. So these are all available for you. Now I can go here to all and search for Mistral since I want to install Mistral. I'm going to click on this, and here is the command to run it on my machine. But you can download it on your machine. Again, it will show you how big it is. It's 4.1 GB. So make sure that you have that much space. If I look at other models, so if I go back here, look at the newest model and go to R1 1776, it is 43 GB. As you can see here, if I go to Deepscaler, that is 3.6 GB. OpenThinker is 4.7 GB. So you can look at how big they are, and then depending on that, decide which one you want. So I'm going to go for Mistral first, and I'll show you how to install it. Go to Mistral, select Mistral here, and then the name is Mistral. So just all that I need is the name. Go back here to my command prompt or terminal, Ollama pull Mistral. Run that. It's going to take a few minutes because it's 4.1 GB. If you install it once, it will not take much time to run it again. Just will check the differences. Since I've recently installed it, it was pretty quick. Again, if I want something else, so for example, I want Llama 3 model, which is 4.7 GB here. I can see, I can just say Llama pull Llama 3. I can install that. It's 4.7 GB. It was instant because I already have this available. Now, these days in news, we have something buzzing, which is DeepSeek R1. So I'm going to go click on this, and this is Ollama run DeepSeek R1. So I'm going to say Ollama pull DeepSeek R1. It's around 4.7 GB, and it took a few seconds for me since I've already installed. Again, if you want something like Gemma model, that is also another popular model, Gemma. So I can go here and say Ollama pull Gemma. Now it's gonna think about it, and as you can see, I have not installed this before, and you see it's downloading right now at 9.8 MB per second, and it says it's going to take 8 minutes for downloading 5 GB. So I am going to go close it right now. I don't need that. I'm not going to play with it. All that I need is Mistral, and I have already installed Mistral, as you can see. So I have that available for us for our building our simple AI agent. So that's, make sure that you have it available, have it downloaded before you go into the next project. Also, another thing that you have to remember is we will be writing some Python code, and there is a video available in this particular section about picking up a little bit of Python based on what we'll be using in this entire tutorial series. So I would recommend, if you are new to Python, go ahead and learn that. If you have not installed Python, I would recommend go to python.org and follow the steps to download Python for your Mac, Linux, or Windows that you're running. So use that, and then look at my video and follow along. It's a pretty short getting up and running with Python video, so you'll probably have some knowledge before we start the next section. Learn Python from scratch, the easiest way possible. Hi, I'm Vivin Arana, and I would like to welcome you to the world of coding. Story time. Picture this: you have a cool idea for a new app or game, maybe something that recommends outfits based on the weather, or a simple text based adventure where you roam a haunted castle. Now, how do you bring it to life? You tell a computer exactly what to do, step by step, in a language it understands. That language is Python. Python is like learning how to chat with your computer. Instead of random beeps and boops, you'll use words and symbols to get the computer to do awesome stuff for you, whether it's math, playing music, creating a website, or making a game. So let's go ahead and set up our coding space. So first step is to go to python.org and install Python on your machine. To do that, you'll go to python.org, and this is the website for Python where you can learn everything about Python that you can, or you can just follow along with me. And then go to downloads and make sure, depending on what computer you're using, Windows, Linux, Mac OS, or other, install that particular Python version. If you're using Windows, you can go in here and download Python from here. For Linux or Unix machines, you can get it from there. If you're using Mac OS, you can install from there. And by default, it will tell you, it will detect automatically what you are running, and it will ask you to install that version right here. So why are we doing this? You need Python on your computer so it understands the magical code you'll write. Think of it as installing a translator who speaks both computer and English. Now, picking up an editor. Now, to write your code, you'll need one of these editors. The first editor that you can get is Thonny, which is from thonny.org. This is a super beginner friendly. It's like a warm hug that helps you learn. Next, we have the Visual Studio Code or VS Code, which is very popular, powerful, and a lot of pros use it. You might like all the colorful plugins. And finally, we have Google Colab, which we'll be using during our course, so we don't have to install anything on the computer, because a lot of times when you try to install things, they break. So instead of running through those issues, why not just use something on the cloud? So as I mentioned, you can go to thonny.org and install it from here. This is one option that you have. Or you can go to code.visualstudio.com and download Visual Studio for you. Or, as what we are going to do in this course, is go to collab.research.google.com, sign in with your Google account, or if you don't have one, create one, and then start coding from here by saying File, New Notebook and Drive, and it will open a new space or a coding space for you to code. And we will look at it in more detail in the next section. So once you have installed Python and chosen an editor, or you decide to do it, follow along with me and do it on the cloud, you're basically set up your coding studio. This is the place you'll create and test all your masterpieces. Next, let's jump into your first line of code. So what we will be doing here is we'll be writing our first Python script. Now to do that, I'm going to open my browser and go to collab.research.google.com. I'm going to close everything here. I don't need any of these. And I'm going to say File, New, Notebook and Drive. It will create a new notebook. The first thing is always make sure you name your file. So I'm going to say first code.ipynb, which means this is a file called as first code. The name is first code, and it's of the type interactive Python notebook. So that's what we're creating here. So it's kind of, you have a notebook where you keep on writing stuff, writing code snippets, and then come back to it whenever you want. And this is my first code.ipynb. I'm going to go ahead and type my first script. I'm going to call a function Now, what are functions? Functions is something that we're going to discuss about a little later. But what I'm going to do is I'm going to write a function called as print. Function means a thing to do for the computer. So I am telling Python that, hey, Python, print hello world for me. So when I do this, I'm telling Python that, hey, print hello world for me, and Python goes, which is a translator, goes to the computer and says, programmer wants us to type hello world and display it to the user opening it. I'm going to go ahead and press this play button right next to it, or it will says here control enter is another option. It takes a little bit of time first time, so have some patience, but going forward it will be much more faster. So we'll run through that code and it will print me hello world. If I say hello Vivian and then run it, it will change that and says hello Vivian. And if you noticed, you see how fast it is. Now usually if you're creating a file, you would probably create as this as hello.py, which is a Python file on your computer, and save it and run it from your command prompt or your terminal, depending on which machine you're using. But if you're using cloud, you can directly run it from your browser itself. So, congratulations, you just told the computer to display a greeting. It's a small step, but every coding journey starts with hello world. Next, let's jump into variables, your virtual boxes. Imagine your room filled with boxes, each labeled with a name. There's a phone charger box, there's a snacks box, there's a guitar picks box. In coding, variables are like these boxes. You label them and put stuff inside them. So let's go ahead and see some examples. I'm going to go here and I'm going to say I want to write another code snippet and click on code. And then here I'm going to create a variable name. Name is the name of my variable. And I'm going to say name is Vivian. It helps me type this without doing anything. This is a string text, which means it's characters inside double quotes. So it's a string. So that's a string text, which means this name variable is saving a string variable, and the value of that string variable is Vivian. You can change this to whatever you want. You put it your name or put hello world in there, but that's what a string variable looks like. This is a string variable. So think of it as a box which has strings inside it, which has characters inside it. Next, I'm going to create an integer, which are whole numbers. I'm going to say age. Now, age is a variable which has integers inside it. I'm going to say 15 here. So this again, this is a box which is named as age, and it contains whole numbers inside it, which is also called as integer in programming languages. Next, I'm going to create something called as height. Now, what happens if it's not a whole number? For example, my height is, let's say, 5'8". So I say 5.8. Now, this is called as a decimal number or a float number. So this in programming languages is called as a float. So the box, which is called as height, has a float value inside it, and that value is 5.8. Now, there's also something called as a boolean, which is true or false. So I'm going to say, is this person a gamer? I created a box which is called which tells me if this person is a gamer or not, and I can set it to true or false. Now this is a boolean, which means the value of this can be true or false. If I'm not a gamer, I'll say false. If I'm a gamer, say true. So boolean can have only two values, true or false. Height, as I mentioned, this is a float or a decimal number, so it can have a lot of numbers inside it. Age is whole numbers, so these are integers. So 1, 2, 3, 4, that's what this contains. And name is a string which you can tell by double quotes. If I remove this, what it means is I'm trying to assign another variable to it, which is not true. So I'm going to give quotes here at the end of it, which means this is the string variable. So we have a string variable, we have an integer variable, we have a float variable, and we have a boolean variable here. Now, if I want to display these out, I can just say print, and I am not going to directly print it. If I directly want to print it, as the computer is telling me, I can do this. I can say print, I can print name, I can print age, oops, I can go ahead and print height, I can go ahead and print is gamer. Now if I try to print this, let's go ahead and press play here. It will execute this and it will go through this. It will create a box called as name. So what Python is telling the computer is create a box, name it name, and assign the value Vivian inside it. Age, assign the value 15. And so computer is creating in its hard disk this particular data and saves it there. And then when I say print, it will go to that box, find what the name is, and display it outside for me. So this is how this works. Now, next option is how do I make it look more pretty? So I can also say that I want to print name and I can just say comma. So what this will do is it will say name of this person is Vivian. So it kind of gives a nice label. So similarly, age, I can say comma, this is the age of Vivian. This is height of Vivian. Let me just make sure I put colons everywhere and make sure you have your commas in place or it will not work. And I'm gonna say is gamer. I'm gonna put a question mark here and then that will tell me whether it's true or false. I'm gonna go ahead and execute it again. And you see name is Vivian, age is 15, height is 5.8 and is gamer is true in this particular case. So now what we are doing is you can open the box called name here anytime to see what the stored value is. In this particular case, we have name as Vivian. I can create another code piece here. And if I print name here, again, it will still work and it'll save it into that box. So every time I want to remove it, I can remove it and check it out. So that covers our variables. Let's go to our next section, which is talking to the user or taking an input from the user from the coding interface. It's like when you log into your gaming console and you say that, oh, I want to play a game, and you'll ask, what is your name? And you enter a name inside there. So we're going to do something like that. So I'll go back to my browser and here in my new coding parameter, if you don't have this, just press this code button and a new snippet will be available for you to type here. I'm going to say user underscore name. So I want to know what the user's name is. So I'm going to creating a variable called as username. And then I take input from user. So I'm going to say input and I'm going to ask the user, what's your name? Question mark. So what this does is it calls this input function, just like our print function, it will call this input function and it will print this out to me and expect an answer from the user. So if I just run this here, you'll see it says, what's your name? And it's asking me input and I can say Vivian Arana, enter. And then username value is Vivian Arana. Now I can do a little bit more is I can say print welcome, comma, and then I'll say username. Now when I run this, I'll play it. It says, what's your name? And I say Vivian, enter. It says, welcome Vivian. So it will go through this line and wait for the user to enter the value before running into the next file. So what we're doing here is we are doing some hardcore coding. Now coding is a conversation with your computer, but what if you want a conversation with the person using your program? That's where input comes in. Now when we run this, as you saw, your program will stop and wait until the user types something. Then it prints a greeting to your user. And if you want to make it more prettier, you can go here and say plus. So what you're doing is you're adding values, but this username is a variable and the rest of the items that I have is more of a string. So I have to put everything under string and I'm going to say add this whatever the variable is in here. If I remove this here and just type it something like this, it will just type welcome comma plus username value, but I don't want that. I want whatever user entered the variable, I want to get that. So print command looks at what did you enter, and if there's any variables in there, it will take that variable and add it depending on how you display it out there. And now when I play it, it's going to ask me again, what's your name? And I'm going to say Vivian, enter. It says welcome comma Vivian this. And if you want to format it nicely, you can always do that and enter any random value and it says welcome comma random and you can play around with it. I hope you were able to get it. If you had any questions or had any issues here, let me know in the messages. Now, to move on to our next step, we're going to do some math magic. Now, who needs a calculator when you have Python? Let's do some quick math. So, I'll go ahead here, create a new code snippet, and here I'm going to create a variable first, x equal to 3. Next, I'm going to create another variable, y equal to 10. Now, what type of variables these are? Now, based on what you learned earlier, these are integer types of variables. Now, if I want to do some math here, I can just type print x plus y. What this does is it takes the first integer and adds it with second. Now, similarly, why didn't it add stuff here? Because this is a string. In string, it just concatenates different strings together and makes an entire sentence out of it. But here, since these are numbers, these are integer types, and they are not inside something like quotes. If I put quotes here, it will display to me 310, something like this. But if I remove this, it will take the number 3 and the number 10 and add it like a calculator. Next, I can also do print y minus x. The reason I'm doing y minus x is y is a bigger number. You can do x minus y too, and it will give you a negative numbers. I can do print, what are the other math? X times y. So this will do a multiplication operation. Next, I'm going to want to do a division operation, which is x divided by y. Next, I want to do integer division, which what it does is it will drop the decimal places, because if you look at 3 divided by 10, it should be like 0.333 something. So it will give me 0 in this particular case. So that is done by using double slash. I can, to make it more clear, I can do y divided by x, and same thing here. Oops, y, yeah, there you go. Our next thing that I want to show is a modulus, which kind of gives you the remainder of the operation. So in this particular case, I'm going to say y modulo x. So it will try to see what is the divisor of this, so and give me the remainder of that. So for example, 3 times 3 is 9. How much is left? Remainder 1, and that's what this will show me as an output. Next, I can do print y star star x. This will give me 10 to the power of 3, which is 1000, and that's what will be displayed to me. Let's go ahead and play it. And as you can see, x plus y is 13, y minus 3 is 7, x times y is 30, then 3.333 for y divided by x, and y integer division gives me just 3 and drops all the points. Remainder y mod x modulo operation will give me 1, and my x raised to 3 will give me 1000. So try making a little calculator program for yourself. It's a perfect beginner project. Next, it's decision time. If, else, if, else. Now in real life, you make decisions all the time. If it's raining, grab an umbrella. Else, just wear shades. Now Python does the same. So we're going to go ahead and write some decision code. So I'm going to go back to my browser and go ahead and create a new code. And here I will say first age equal to integer of, so I'm going to ask user, what is your age? And for that, I'm going to say input, enter your age. The reason I am saying int in front is because if I just do this, whatever user enters will be taken as string. So if I enter 25, it will just enter my age as 25 as a string. But I want to convert it into an integer. So I can say, I can add int in front of it in brackets, and then whatever input user enters, so if I say 25, it will convert that into a number, an integer number, and assign it to age. So that's why I'm using int here. And now it's decision time. So I'm going to ask a question. If age, I'm asking the computer, if age is greater than equal to 18, I'll say print you are an adult. Also print, or else print you are a minor. So that's an if else statement. So now not both will be ever displayed, because if I enter my age as 18, it will display the first one, you are an adult. If I say 15, it will not print this one because this is false here. If age is greater than or equal to 18, if I say 15, it is less. So it will say print, you are a minor. So go ahead and run this. It will ask me what's your age, and I'm going to say 15, and it goes through this and it looks at this decision here, makes a decision, looks at the value and checks it's 15, which means it should not run this, and it will run else loop here and print this. If I run it again, and this time I'll say my age is 33, enter, you see you are an adult because it runs through this decision here if age is greater than 18, which is true in this case, and it will print this and it will ignore the else side of it. I can also use else if, where I can say here ELIF, that is else if age is, let's say, greater than 13, you are a teenager, else you are a minor. If it's less than that, then it's a minor. So if I run this here, and now I have three different conditions that I have to looking for. If I am 25, it will say you are an adult in this particular case. If I run it again, and I'll say my age is 15, in this case, it will, I just stopped this, let me run it again. If I say 15 and enter, it will check the value here, greater than 18, nope. And then it will check else if age is greater than or equal to 13, it is, it's 15. So it'll say you are a teenager. And one more case, if I say I am 10 years old and run it, it says you are a minor. So that's how if else works. Now next, we are going to look at loops, which are repeating actions. There are two different loops that I want you to look at. First is the while loop, where you want to go over something over and over again until a particular scenario is met. For example, maybe you want to do 10 jumping jacks, so you keep counting until you hit 10. So that's how you write a loop. Now you don't want to write it hard coded into the code where you can say, okay, jumping jack 1, jumping jack 2, 3, 4. Instead of that, you can write a loop. So let's look at how to write a while loop. I'm going to go ahead and open my browser, and here I'm going to create another code piece, and in this particular case I'll say count equal to 0. So I'm creating an integer variable here, and then I'm checking if while count is less than 5, in this particular case I am going to say count is this value, and then I want to reduce the count. Now the one way to do reduce the count is count minus 1. So what I'm doing here is I'm checking, is count less than 5? In this case it's 0. So I am going to say, so I think I have an error here. Instead of reducing, I want to increase it. The reason is I'm checking if the count is less than 5, it is less than 5. I'm going to say print count is, in this particular case it will print as 0, and then it will go ahead and increment the value of count by 1. So whatever the initial value is 0, it will increment by 1, and now the value of count is 1. And it checks again, while count is less than 5, 1 is less than 5. So it's going to go ahead and print it again. Again it will go in and increase the value. From now 1 becomes 2. Now this is increment operator, where you can directly say, instead of doing that extra work, you can say plus equal to 1, where it increments. If you want to decrement, you minus equal to 1. So since I want to increment, I'm going to do this, and now when I run through it, what it will do is initially it will print when the value of count is 0. It's a print count is 0, then add 1 to it. Now the value of count is 1. It will check again. I'll say 1, 2, 3, 4. Now when it's printing count is 4 here, it will check count, it will increment by 1. Now value becomes 5. Now is count less than 5? Is it still less than 5? 5 is not less than 5. 5 is equal to 5. So it will come out and close the program. That's what's happening here. Now this code, as you can see, prints the count from 0 to 4 one by one. Now if I want to do it for 10 times, you can save it, run it. It will say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 until value is met. Similarly, you can do 100, thousands, whatever you feel like, you can add it here. Next, I want to talk about for loop. Now, for loop is used where you have a list of chores and you want to go through them one by one. So you are given a list in this particular case. So for example, you have 10 video games and you want to find the right game to play. So you go through each one of them until you find it. And when you find it, you can stop going through the disk set, or you can just keep on continuing if you want to see if you have two of those. So I am going to go ahead, add another code snippet here, and then I'm going to say video underscore games equal to, and I'm going to make a list. Now to make a list, I can use square brackets, and inside that I can say game 1. Next I can say game 2. Next game 3. So let's say I have 3 games here. Now I want to go through each and every game and then print these games that I have. So for that I can say for game in video games, I want to print the game name. So what it does is it will go through each and every one inside here. So first it will go to the first one, it looks at this name and assigns it to this, and then prints it out. Then it goes to the next one, does the same thing, assigns it to this variable game and prints it out third. So it will keep on going through that. So if I run this, and as you can see, it prints each and every game out for you. So that's our while loop and for loop. Next, let's look at lists, where you keep track of all your stuff, like video games that we just did. Now a list is a playlist on Spotify. It contains a bunch of items in a particular order. So let's say your music orders. Now of course you can shuffle them, but let's say if you want to go through in a particular order, that's what lists are used for. Now, let's look at some of the functionalities that lists provide. So we already created a list here. We have a game list. Now I am going to go ahead and comment this. When I put the hashtag or pound in front of any of my line in code, what Python does is it just ignores that line of code. So if you see here, nothing is happening because it just go through this and then it will ignore this and it will ignore this. So what this pound sign does, it tells the computer, the code is telling the computer, just ignore it, don't do anything with it. So all it does is it creates a list with 3 games inside here. Now if I want to look at my first game, I'm going to say video game of 0. I don't want to see all of them, so I'm going to just say video game of 0. What that will do is that will just print me the item in the first element. Now why didn't I say 1 here? The way lists work is they start with an index 0. So this is 0, this is game 1, and this is game 2. How many items do I have? I have 3 items in here. So length of this list will be 3, but the index or the ranking starts with this is the 0, this is 1, and this is 2. So if I say video games of 0, it will print me the first item in here, which is game 1. Now next, I can add items to this video games list. I can say video games dot append. I want to append a game 4. And now if I want to look at what I have inside this video games variable, it's already was a list of 3 items, and I'm saying append add game 4. So I should see the 4th game. I'm going to go ahead and comment this because I don't want to see this line printed. It goes through this and it looks at this and it will print out game 1, game 2, game 3, game 4. I can also change a particular item inside here. I can say video underscore games, and inside the first item for index 1, which is this one, index 1, I want to change that and call it game 8. So think about it, you have a drawer of or a box of items, and then you want to remove the second item and replace it with something else. That's what I'm doing here. Now let's go ahead. I'm going to take this code here, put it down here, and run. So if you see game 1, game 8, game 3, game 4. What happened to game 2? So what I did by doing this is I took the game 8 and I replaced game 2 with it. I threw away the game 2 and game 8 was added in place of game 2. And that's how you do that in lists. So that takes us to functions. Now we have already called some functions. We've called the print function. We've called the input functions. What functions let you do? Let you build your own commands. So whatever functions we've used till now are the ones that are available by Python, which was print and input. But now imagine you can do a certain task a lot, like sending a greeting message. instead of copying the same code repeatedly, you define a function once and then call it whenever you want. So for example, let's go back to the code and create a new one. And here I am going to create a function. The way to create a function is you say def. This is how you define a function, and then you give the name of the function. Say underscore hello. So that is my function name. And inside here, so if I want to put anything inside a function, I give a colon and then enter next line and make sure this is indented, because whatever is indented is in part of the function. So I can say print hello from your very first function. Okay, so that's there. Now I'm going to get out of the function by going back, and I'll call that function by saying say hello and then brackets next to it. So that's how you create a very simple function, and I can call it like multiple times. It will, let's say, it will keep on printing hello from your very first function, hello from your very first function. Depending on how many times you call it, it will call this function and it does whatever you ask it to do inside the function. So that's how functions work. Now we've seen like print, and then we gave some video games inside here. There's no value here. So these things are called parameters. The variables that you give inside are called parameters. So what I am going to do is I'm going to say that this function takes a parameter called as person name, and then instead of like here I am going to append to that the person name to it. So it says hello, whatever the name is. Hello, let's say I pass Vivian. Hello Vivian from your very first function. That's what will be printed. Now this doesn't exist anymore here. Since I say hello and I gave empty brackets here, it doesn't exist anymore because this function takes a parameter. So I can say here hello Vivian, and I'm going to remove everything else. Now what happens here is I say hello, and instead of giving a variable, I gave the value of a variable, which is a string. It will take that string value and assign it to this variable, and then it will say print hello, pass that variable name's value in here. You say hello Vivian in this case from your very first function. I run it. I'll say hello Vivian from your very first function. Now if I want to change this to, let's say, Clyde, and run it, it will say hello Clyde from your very first function. Now depending on what the user says their name is, you can give a personalized message and just call this, and don't have to write this as a part of your code, and you can reuse this as many times as you want. Now another thing that this can do is it can also return, functions can return values back to whoever called it. So for example, I want to create another function which multiplies two numbers. So this takes two numbers. You have to pass two numbers as parameters, and what it will give you back, it will return back. So you have to specifically say a return a times b, and then I'll go to the next line, and here I will say result. I'll create a variable called as result equal to, let's say, multiply 3 comma 5. So what I'm doing here is I'm calling this function multiply, and I'm passing values 3 and 5 to this. So variable a's value will be 3, variable b's value will be 5, and it will return back a times b, 5 times c, 15, back to this result variable, and then I'm printing this out here. I can always say result comma, make it look nice, play, and now if you see here result is 15. Now I just change the value here, let's say 15 times 3, run it, and it will say 45. How about 30 times 15? It will just be one more 0, 450. So there you go. So this is how you can pass or call this multiply function again and again, bunch of different times. So this brings us to our next part, which is a mini project, number guessing game. So we will be writing a game using whatever we have learned till now. We'll use random numbers, we'll use loops, we'll use conditionals, we'll use input from the user, you name it, we'll use everything. Again, we've not looked at random numbers, but we will be creating random numbers. So to do that, first, let me go to my browser, and I'm going to create a new code here. And inside this, I'm going to import something called as random. Now this is a library that Python provides us, which has some functionalities or functions that creates random numbers for us. So I am going to say secret number. This is what computer will give me, random dot random integer 1 comma 10. So what this will do is this will create me a random integer number between 1 and 10, and that will be assigned to secret number. Now I don't know it, you don't know it, we don't know what it is. The only person who knows about this secret number is our Python code and the computer which generated it. So I am going to say the user has 3 attempts to solve this. So I'm giving user an opportunity of 3 attempts, which I will reduce every time user guesses the number. Next, I'm going to tell the user print I am thinking of a number, if I can type properly, between 1 and 10. So I'm asking the user, can you guess a number? Now I'm going to check first while attempts is greater than 0. So if the user has still any attempts left, the user has 3 attempts, attempts is greater than 0, I'm going to say guess equal to integer input. Since user has options, I'm going to say take a guess. Another good part about this editor here of Google Colab editor is it completes your code for you. So if you are stuck somewhere, it will help you complete the code for you. So anyways, so now I am taking a user's input here. User will say, let's say 5, that I'm converting into int, and I'm assigning it to value guess. So then I am going to check here if guess is equal to secret number. I'm going to say congratulations, you have guessed the number, or I'll say break. So I'll get out of this loop and I'll say else. If guess is less than, I'm going to say too low, else I'll say too high, and then I am reducing the attempt by one more, -1. Next, I'm going to check how many attempts are left. If attempts, oops, attempts equal to 0, I'm going to say sorry, you run out of attempts. The secret number was whatever the number was. So what I'm doing is I'm telling the user you have 3 attempts and asking the user, so if the attempts is greater than 0, so first time it will be 3 attempts. User will say, let's say the secret number is 5. The user will say, let's say 8, and then I'll check if 8 is equal to 5. It's not. So I'm going to say, wait, your number is too high. The number is 5. So kind of depending on what the user guesses, I will give them a hint saying too low or too high, and then I will reduce the number of attempts. Again, the user will try to guess, and if the user runs off all the attempts, which is 0, then I'll say sorry, you've run out of attempts. The secret number was, I'll give the number. So let's go ahead and play this game, and if let's see if everything works fine. Say play. Think your number between 1 and 10. Take a guess. I'm going to say 5, and it says too low. Try again. So it means it's between 5 and 10. So I'm going to say my second attempt, I'll say 7, and it says too low. Try again. So that means it's between 7 and 10. So I'm going to say 8. Too low. Try again. So I think it was, in this case it was 10 and not 8. So it guessed a number very high. I'm going to run it again. Take a guess. I'll say 5. Too low. I'm going to say 8. Too low. What is again? 10 again. Congratulations, you guessed the number. It guessed 10 twice. Let's try again. Let's see. I'm going to say 5. Too low. Is it 10 again? Too high. Okay, so it's between 5 and 10. I'll say 8. Oh no, it was 9. It's kind of trying to guess pretty high numbers. Let's see if it can guess a low number. 5 too low. Okay, again. 10 too high. 8. No, it was 6. Anyways, enjoy this game. I hope you were able to build this game and play with it. If you had any questions or issues while implementing this, let me know. And now I think you're ready to deep dive into Python programming. So now that we have our entire environment set up, let's go ahead and build a simple AI agent. Here, Let's build an AI powered chatbot using LangChain and Ollama. So first step, what we'll do is we'll install the required packages, and then we will go ahead and create a Python file which is called basic underscore AI underscore agent.py. So let's get started. I'm going to go to my Sublime text here. I already have an AI agents folder available in here. I'm going to create a new folder in here. I'm going to call this day one, and inside that I will create a new file. I'll call this file as, what did we call it? Basic underscore AI underscore agent. So I'll call it basic underscore AI underscore agent dot py file. Now, as I mentioned, our first step is to install the required packages. So I'm going to go here to my terminal. Some if you're using an environment, Python environment, I would say use run this anyways. But if you have already installed this before, it should be pretty quick. So I'm gonna see where I am. I am in AI agents. Inside that, I have my day one folder, and inside this, I have this file. So I'm gonna go ahead, clear it, and first I'll install the required libraries. So I'm going to go here and say pip install langchain, langchain dash community, and langchain dash Ollama. Now, what are this? Now, to install langchain, langchain community, and langchain Ollama, these are the required libraries. You can use the pip command. Pip command is something that comes with Python. If it's not there, you'll probably have to go ahead and install it. You can open the terminal and just say pip install langchain, and langchain will be downloaded and installed install the latest version from the Python package index, which has pypi. For langchain community, you can just add langchain community in here, and then for langchain Ollama, you can use langchain Ollama. Now again, if you've never heard of these, LangChain, the core functionality helps you with the core functionality for building LLM based application. It provides component like chains to combine different LLM functionalities. It also supports integration with various LLM providers like OpenAI and Hugging Face, and that's why we are installing that. Next, we have LangChain community. This is a community developed additions to LangChain with new features and functionality. It keeps on updating, so it's good to keep it, install it every time, just so that if there's some new features or something new you're using, it will be available for you. And it often includes experimental features or support for niche use cases. So that is very helpful. Next, we have LangChain Ollama. This allows users to leverage Ollama to run open source LLMs locally within their LangChain applications, and it enables privacy and control over data by running models on our local machine. So that's what we'll be doing. So that's why I need this, and I'm going to go ahead and run this. It's going to take a few seconds and install everything. And if you see any error or anything that is wrong, just let me know in the messages and I can help you out with that. But our next step, again, to go back to this basic AI agent, and here we're going to write the code for our basic AI agent. I'm going to start with importing Ollama LM. So for that, I'm going to say from LangChain, which we just installed, Ollama import Ollama LLM. Here what I'm doing is this line imports Ollama LLM class from the LangChain Ollama package that we installed. Ollama LLM is an implementation of a language model that uses Ollama, a framework for running and interacting with AI models, which we have already installed and it's running on our machine. Now, this allows us to interact with AI models like Mistral, which we have installed. You can also use Llama 3 or others through LangChain. So this is available to us. So I'm going to save this. Next line, I'm going to go ahead and say that I want to load AI model from Ollama. And in here, I'm going to say LLM equal to Ollama. I'm going to use that Ollama LLM and say model equal to Mistral. Now you can change this Mistral to Llama 3 or whatever you want, depending on which model you want to use. This initializes the AI model. The Ollama model equal to Mistral creates an instance of the Ollama LLM class and assigns it to the LLM variable. Now, Mistral, as I mentioned, specifies the model being used. You can replace it with Llama 3 or Gemma or anything else that you want that is supported by Ollama. Now, the LLM object here will be used later to generate responses based on user input. So keep that in mind. And with that, I'm going to go next line and say print. I'm going to give a small message to the user /n welcome to your AI agent exclamation mark, and here I'm going to say ask me anything. So this is what I'll display to the user in the CLI. So that will run, and once that I have that, I'm going to run a while loop. So what this does is while true, it will run constantly and ask user questions. So I'm going to create a question variable and I will ask user. So input is used to take user's input. So after it displays this message, it will wait for user to specify something. So I'm going to say your question or type exit to stop. So the reason I'm giving the user option to exit is if user wants to get out of this loop and don't have any more questions, they can just type exit and get out of it. Next, I'm going to check if question dot, like sometimes what happens is even if you see exit and you write it in capital, I'm going to convert whatever user enters. So whatever user enters is assigned to question. I'm going to check if that is equal to oops, exit. If whatever user entered is exit, what I'm going to do is I'm going to print goodbye. Okay, and then go ahead and break out of this while loop. So this will close my application. Next, I am going to say if not, I'll say response equal to, I'll ask LLM, I'll invoke that function. So what LLM dot invoke does is it sends the user's question to the AI model. So I'm going to pass the question here, and so this line actually passes the question to the AI model and generates and gets a response back from the model. So the response is stored again in the response variable. So now that I have that, I'm going to say print /n AI response is response. So that's pretty much it. So what this will do is this will, again, to go through the entire thing, I have imported from this LangChain Ollama LLM, which I'm using to connect to my Ollama server that is running locally with the model Mistral. So I'm saying use the model Mistral to run whatever commands that I'm using. Next, I'm going to print a message to the user, and I'm running a loop constantly, which will keep on going over and over to get users output. Here I'm saying question equal to input your question or type exit to stop. I'm giving an option for the user to exit out of this loop. If the user says exit, I will say goodbye and get out of this and close the application. Or else I'll say response equal to, I'll call that LLM and I'll say invoke, open it, and pass the question that user gave here. If it's not exit, probably user says what is AI, and I'll pass that response back to the user, print it out to the user, and then again run through the same loop over and over again. So let's go ahead and run this and check it out. So I'm going to go here and I am going to say, let's make sure we are in the right folder. Yes, there is. So I'll say Python basic AI agent.py. There you go. Welcome to your AI agent. Ask me anything. So your question here, I'm going to say, what is AI agent? Question mark. And it's going to go back to the Ollama server and ask this question, and it'll say use the model Mistral, and whatever it gets back is going to take that response and give it back to me, and it will print it right here. And there you go, we have the AI response. It says an AI agent is a software entity that perceives its environment, decides on actions to maximize some utility or objective, and takes those actions and gives more information about it. I'm going to say, can it learn automatically? And then again, it will take this question, send it back, and it says, yes, I can learn and adapt. Now, I didn't ask, can you learn? I asked, can AI agents learn? And what happens here is it doesn't have its own memory right now. We are not saving users' questions and we are not creating a context. We're going to learn how to create a context in the next step. I am going to ask, what is the first question I asked? I'm going to ask that and see the first question that what is the first question I asked. So according to this is the first question because it doesn't keep the context. Whatever I asked is the first question every single time, so it doesn't keep context. So for that, we'll have to use the memory option. But for now, I'm going to go ahead and exit. And if you were able to get this working, perfect, successful. So we were successful in creating our first basic AI agent right over here. I'm going to go ahead and clear it out. And again, if you had any issues or problems implementing this, let me know in the messages and I'll get back to you. So let's talk about, so something that we saw in the previous video was we were not able to make the AI agent remember things that we asked. Every time I ask something, it thinks of it as a new, as it is a new question. So right now the AI agent forgets past conversations after each response. So what we'll do is we'll use LangChain's conversational memory to keep track of interactions. So what we'll do is we'll install the memory dependencies first, and then we'll modify our existing application to add memory to it. So for that, what I'm going to do is I'm going to go back here, and first I am going to install a library called as langchain underscore community. That is where it exists. Again, if you remember, we have already installed it, but if you have not, make sure that is installed. I'm going to go ahead and clear it, and now I'm going to go back here and update this code. So to start with, instead of updating this, I'm just going to comment this out first and then move it to the bottom and start coding here. So the first step is from langchain community dot chat underscore message underscore histories, import chat message history. This will import chat message history class, which is used to store and manage chat history. This allows the AI model to remember previous interactions in the conversation. So we are using that library, and that's why we went and imported this LangChain community. Next, I'm going to go ahead and from LangChain core dot prompts import prompt template. This imports a class prompt template which is used to define the structure of AI prompts. This helps format the input before sending it to the AI model. So that's why we're using this. Next, I'm going to say from langchain underscore Ollama, import Ollama LLM. This is the same thing that we imported here on line number 13, as you see, this same Ollama LLM. This imports again Ollama LLM, which allows us to use an AI model from Ollama via langchain. This is the AI engine that will generate responses. So let's go ahead and load the AI model. Now to load the AI model, the same thing that we did before, we're going to say LLM Ollama model equal to Mistral, and change this model to Llama 3 or another if you want to test around with something else. Again, this initializes the AI model Mistral using Ollama LLM, and the model can be changed again to anything that you want. Next, let's go ahead and initialize memory. So this is initializing the chat memory, where we are going to say chat history equal to chat message history, and this stores the user AI conversation history. Here what it does is creates a chat memory history to store the conversation history here inside this chat underscore history. This allows the chatbot to keep track of what was said earlier. Next, I'm going to go ahead and define the AI prompt template. Here I'm going to say prompt equal to prompt template. This is something that we imported here, so that's what I'm using. And here inside this, I'll say input variable equal to chat underscore history and the question, and template equal to previous conversation was chat history, and the user is asking this question, and then AI is saying this. So that's what I'm going to close here. What this does is this defines a structured prompt that the AI will use with chat underscore history will be replaced with the stored conversation history, and the question will be replaced with the latest user input. This ensures that the AI responds in context by seeing the past messages. So every time it might be getting those messages, but it will know what the previous chat history was, and based on that, it will keep track of that. Next, let's write the function to handle the AI chat with memory. So I'm going to say function to run AI chat with memory, and create the function run underscore chain question. This defines a function that processes the chat that happens. And go ahead and say retrieve the chat history normally. Here I'm going to say chat history underscore text equal to slash n, which is next line, dot join f of, so I'm making a string here, a formatted string, message dot type dot capitalize message context for message in chat history dot messages. So I'm kind of creating this format the stored chat history into a readable format, and each message is processed into user colon message and AI colon response. So that's how it kind of displays, like stores here in the chat history text. Next, I'm going to go ahead and run the AI response generation, where I'm going to say response equal to llm.invoke prompt format chat history. I'll pass the chat history text, that is we have here question equal to question. This is similar to calling this LLM invoke that we did before in the basic agent creation. So that's what my response will be. This will send the formatted chat history and user question to the AI model. The AI generates the response considering previous messages and pass that to response. Next, I'm going to say store the new user input and AI response in memory. So I'm going to say chat history dot add user message, which was the question, and also chat history add AI message, which is the response. So this saves the user question and AI response in chat history. This ensures that AI remembers past messages in future responses. And finally, I'll say return response. This will return the AI generated response to be displayed in the chat. Now let's go ahead and create the interactive chatbot loop. So here I'm going to say print AI chatbot with memory. Next, I'll say print type exit to stop, the same thing that we did. This will print a welcome message explaining that this chatbot remembers the previous messages. So, and then here I'm going to run that same thing while true, which starts an infinite loop allowing continuous chat until user exits. Next, I'm going to say user input equal to input, and I'm saying you, which means you can type something. So this prompts the user to enter a question. Next, I'm going to say if user input dot lower equal to exit, which checks if the user wants to exit here, print goodbye, and then break out of the or enter exit the while loop. Next, if it's not exit, I'm going to say AI response equal to run chain. I'm calling that function with the user's new input, and then I'll say print AI response, which displays the AI's response. So that's our entire application with memory incorporated. So I'm going to go ahead here and run that same application again. It's the same file, Python basic AI agent.py, and it says AI chatbot with memory, type exit to stop. Here I'm going to say what is AI agent question mark, and now again it will follow the same process, but it will remember this, it will save this into memory, and I'm going to ask uh, who invented AI. Let's see what does it say, and I can say can it learn by itself. Run it. Again, if you see, want to read through an AI agent, what it is, yes, some AI systems can indeed learn automatically. And now I'm going to ask what was the first question I asked. Make it a little bit above. And so your first question was, what is an AI agent? If you remember, that was my first question. Now it remembers. So it kind of has the context of what I'm doing and kind of resumes the next session with that context. So whatever you ask, you can have like a normal conversation with this AI agent. And finally, I can just exit and it quits out of it. So that's how you can add memory to your AI agent. So again, if you had any issues or problems in this, let me know in the messages and I'll get back to you. Our next topic that I want to cover is building a web UI for AI agent. So we already created a command line interface, which is great, but let's add a web-based UI using a library called a Streamlit. It does everything for you and it's very helpful. So what I'm going to do for that is first I'm going to install it. So you can go to your same command prompt or terminal and say pip install Streamlit. You can read more about it just by searching about Streamlit and then know what it does. But I'm going to implement it and show you how this is used. So I'm going to go back. So the steps that we'll follow here, as I mentioned, let's add a web-based UI using Streamlit. We're going to install Streamlit first, which we just did, and then we're going to create a web interface. So let's get started with the web interface. I'm going to go back to the same application that I've created, which is our basic AI agent here. And I'll go all the way to the top here. Again, do the same thing. This was my memory one, so I'm going to go ahead and comment this out. Just for your reference, what I'm going to do is I'm going to say basic AI agent here, and next here I'm going to say basic AI agent with memory, and then this one is our basic AI agent with web UI. So save this, and here I'm going to start with importing Streamlit as ST. This is the Streamlit is which is a Python library for creating web-based applications quickly. It is used here to build a simple AI chatbot UI. So that's why I'm importing it. Next, I'm going to say from langchain underscore community dot chat messages underscore histories import chat message history. Again, we've used this. This imports chat message history, which helps store and manage the chat history between user and AI. Next, I'm not going to go into details about prompt template. We have just recently used it, and also Ollama LLM. So these are imports are available. Next, I'm going to go ahead and load the AI model. Again, you remember this LLM is equal to Ollama LLM, model equal to Mistral. You can change this to any other model that you want. Next, I'm going to go ahead and initialize the memory. In this case, I'm going to say chat history not in st.session state. st.session state dot chat history equal to chat message history. This stores the user AI conversation history. So again, why st.session? So this checks if the chat history exists in Streamlit's session state, and it says st dot session state dot chat history equal to initialize. So if it doesn't, if the chat history is not already set, it initializes the chat history here, or say chat history object here, and then this allows the chatbot to remember past conversations. Next, I'm going to go ahead and define the AI chat AI prompt template, which I'm going to say prompt equal to prompt template. Input variables is again chat history and question. This is same as what we did before. Template equal to previous conversation, chat history, and question, and then close it. This again defines how messages are sent to AI. Next, I'm going to go ahead and say function to run AI chat with memory. This will exactly the same function that we have. There are some changes in here, which is I'm going to say retrieve past history. Now in here I say chat the history equal to join slash and join message capitalized. Now in here I'm taking st dot session state chat history dot messages. So that's how it is different from what I've done here. If you look at the differences in here, before I took the messages from chat history dot messages, but in this case I'm saying st dot session state dot chat history messages. Next, I'm going to go ahead and run the AI response generation. Response is LLM invoke prompt format chat history is chat history text this thing, and question is question. I'm going to say store the new input and AI response in memory by saying st dot session state dot chat history add user message this question. I'm going to also do the same thing for AI message. I'll say st dot session state chat history message chat history dot add AI message. It's same as what we had before, but just that we are using that st streamlit here. And then I'll say return the response from this function. Next, let's go ahead and create the streamlit UI. So this is new for us. And here, what I'm going to do is first, I'm going to create Streamlit has something called as a title. So st.title, this will be title that will be displayed prominently. I'll say AI chatbot with memory. Next, I'm going to say st.write, ask me anything. So this will be displayed in the message. So again, this sets up the web UI using Streamlit, where st.title AI chatbot with memory displays the chatbot title, and the second part displays a short instruction to the user. Next, I'm going to go ahead and take the create something for user input. User input equal to st text input your question. This will create a text input field for user to type their question. So when you open the browser, you'll see what I'm talking about. Next, process. Let's go ahead and process the user input. Now, if user input response equal to run chain user input, so I'm going to call that function, get the response, and I'll say st.write. You said user input, st.write. AI gave this response. Now, if the user enters a question, it will go through this run chain and sends it to the AI to get a response. The user's questions and the AI response are displayed on the web UI using these messages. Next, let's go ahead and show the full chat history. For this, what I'm going to do is st.subheader chat history. So this displays the full chat history on the UI. It loops through, let's go ahead and loop through the chat history and print each message. So I'm going to say for message in st.session state dot chat history dot messages. So I'm going through each and every message, and I'm going to say st.write I'll create a string, format a string, message dot type dot capitalize and message dot context. So that's our entire application here. What it does is, again, it creates a Streamlit web app where users can chat with AI. AI remembers past conversations which are stored in session state, and it displays complete or full conversation history dynamically. Let's go ahead and run this. Now, to run this, what you do is you go to your, again, same place wherever this was. I'll say Streamlit run and the name of the file, which is basic AI agent.py. It's going to go ahead and open a URL just like this here. It opened a URL on my browser as soon as it went there, the localhost 8501. If it doesn't open, you can just copy this and then open it in a new browser. I'll show you the same thing again. Now, as you can see, the title that we have specified here, which is AI chatbot with memory, is displayed here. Let me close this. We don't need this. AI chatbot with memory, and then ask me anything is displayed here. Your question that I mentioned here is displayed here with a text box available. Also, the chat history is there, but there's no chat, so that's why it's empty. I'm going to say, what is AI agent? Okay, so it's going to go ask. So if you see, it's running and it gives me the answer and also shows me the history here. What did the human say? What did AI say? Again, here is my, I can put another question. I say, can it learn by itself, question mark, and it will take both the questions and then send it again and says yes, an AI agent can learn by itself. So here is my question, here is the answer, here's the question, here is the answer in the chat history. I say, what is the first question I asked? Run it. It's going to run, and then there you go. It says the first question that I asked was, what is an AI agent? And that's what I asked right here, as you can see, and it remembers. So this is your entire chatbot with memory available on a website. So we created a web-based chatbot using Streamlit. Try this out and let me know how it goes. If you have any questions or had any issues implementing this, let me know in the messages and I'll get back to you. And that's our end of day one. So I hope you enjoyed this day one. So I'll probably see you in day two tomorrow. Welcome to day two for hands-on AI agents course. Today we'll be building a personal AI assistant. The goal for today is we'll build an AI-powered personal assistant that can understand voice commands, which is speech to text. Next, we'll do respond with natural sounding speech, where we'll be doing text to speech, and we'll remember past conversations and perform useful tasks like opening apps or setting reminders, etc. So by the end of today, you'll have a fully functional voice control AI assistant. So let's get started with our AI powered personal assistant. Our first step is to install required dependencies. So before we start coding, let's make sure we install some of the necessary Python libraries. So let's talk about what will be installed. We'll be installing speech recognition, which converts spoken words to text. We'll be installing a library called as PyTTSX3, where TTS stands for text to speech, which converts AI responses into speech. And then we'll also be using LangChain Ollama, which runs Ollama AI locally for response generation. So I'm going to go ahead here. I am already in the AI agent. So I'm going to go ahead and create a new folder here for our day two. I'll call it day two. That's what my file. Inside that, I'll create a new file. But before that, let's go ahead and install our dependencies. I'm going to say pip install. I said speech recognition. This is again used to convert spoken words to speech. Next, we have PyTTSX3, which converts AI responses into speech. And finally, our LangChain underscore Ollama. Okay, so once I install those, that's all good. I'm going to go ahead and clear it. It might take some time if you have not installed it. If you have already installed it, you don't need to install it again. So that completes our installing dependencies. So our next step is to build the AI voice assistant. Here, let's create the Python script that listens, processes, and responds. So I'm going to go ahead and create a new file in my day 2 folder. And this file, I'll call it AI underscore voice underscore assistant dot py. So that's my Python file. And here I'll start with importing the libraries that we just installed. So first one was import speech underscore recognition as SR. This imports the speech recognition module for converting speech to text. Next, I'm going to say import py-ttsx3. This imports the py-ttsx3 library for text to speech conversion. Next, I'm going to import chat message, which is available in langchain underscore community dot chat messages history. This is a class from langchain that maintains our chat history. Next, I'm going to import prompt template from langchain underscore core dot prompts. This is a langchain utility that defines the format of AI prompts. And finally, I'm going to import Ollama LLM from langchain underscore Ollama. This is a class for using Ollama models like Mistral or Llama 3 for AI responses. Again, we have covered some of these things in the previous videos, but I'm going to go ahead and repeat again today, because if you have not looked at day one and directly jumped into day two, I would want to go over each and everything properly again. You can always forward or skip to the end to look at how the project looks like. Now, next step is to loading the AI model. I'm going to go ahead here and say LLM equal to Ollama LLM model equal to Mistral. This initializes the AI model using Ollama LLM, specifically the Mistral model. You can replace the Mistral with other models like Llama 3, Gamma, or DeepSeek, or anything if needed. Now next, let's go ahead and initialize our chat history. So this is initializing chat memory. This is good for LangChain version 1.0 and above, so it will work perfectly. So here I'm going to say chat history equal to chat message history, and I'll create this class object. This stores past conversations between the user and the AI inside it. This is useful for context-aware responses, which we would need, or which we need in any chat application these days. Next, I'm going to go ahead and initialize text-to-speech engine. For that, I'm going to say engine equal to py-ttsx3.init. This initializes the text-to-speech engine. Next, I'm going to say engine.setProperty rate of 160. This is your adjusting to your speaking speed. This sets the speech speed. Default is usually around 200. 160 is slightly slower for clarity. Next, I'm going to go ahead and initialize the speech recognition here. I'm going to say recognizer equal to sr.recognizer. Again, sr is the speech recognition class that we have added here, or module that we've added. This will create an instance of recognizer to convert speech into text. Next, let's write our function to speak. I'm going to say def speak text. Inside that, I'll say engine.say whatever text is passed to it. This sends the text to the speech engine. Next, I'm going to say engine.run and wait. This processes and speaks the text. So until the text is spoken out, it's going to wait for it. Next, I'm going to write a function to listen. This is speech to text conversion. Here, I'm going to create def listen with sr.microphone. So speech recognition.microphone as a source. So this uses the microphone to capture the audio input. And I'll print listening. So we know that the microphone is on right now. Next, I'm going to say recognizer.adjust for ambient noises. This reduces the background noise, so that's why it kind of looks for adjust for ambient noises. Next, I'm going to say audio equal to recognizer.listen from the source. This records our user's speech. So next, what I'm going to do is I'm going to go ahead and try to get a query equal to recognizer.recognize Google audio. This converts speech to text. It uses Google's speech recognition API to convert speech to text. Again, we have not signed up for it, but it's available for us. Next, I'm going to say print you said, and whatever that query that we get, I'm going to print that out. And then finally, I'll say return query.lower. This converts to lowercase, and I'll return it to whoever called this function. Next, I'm going to go ahead and look for exceptions. So I'm going to look for first unknown value error. If speech isn't recognized, it asks the user to repeat. So I'm going to say, sorry, I couldn't understand, try again, and return out of it. And another exception is request error. If Google service is down or unreachable, it notifies the user here. It says speech recognition service unavailable and return. Next, I'm going to go ahead and say create our AI chat prompt format. I'm going to say prompt equal to prompt template, and inside this I'll put input variables chat history and question, and template equal to previous conversation chat history, which is chat and then user question AI colon. So what this does is this defines how AI should generate responses. The chat history that we have here stores the past conversation. Question is the user's latest input. And finally, with all these, I'm going to create a template here which says previous conversation, chat history is whatever we got, and user's question is here, and what AI response will be displayed here. So the AI sees previous message and the new user question before generating a response. Next, close this, and I'm going to create a function to process the AI responses. I'm going to create a function called as def run chain question, retrieve the past chat history manually first. I'm going to say chat history text slash n join message dot type dot capitalize message dot content for message in chat history dot messages. What this does, it will retrieve the past messages from chat history and format them here. Next, I'm going to run the AI response generation. Here I'll say response equal to llm.invoke, take the prompt, dot format, chat history equal to chat history text that we have here, and question is the new question that comes in. So this generates AI responses by formatting the prompt, sending it to Ollama LLM model Mistral, and getting the AI's reply. So once I get that, I'm going to store the new user input and AI response in the memory. So I'm going to say chat history dot add user message, whatever the question is, and chat history dot add AI message, whatever the response from AI was. So this will return the AI response to be spoken or displayed. So that brings us to our final main loop, where I'm going to say speak hello, I am your AI assistant, how can I help you today? This is just a greeting message for the user to start speaking. So I'm going to say while true, I say query equal to listen. So this continuously listens for user input. Next, I'm going to say if exit in query or stop in query. So if the user says exit or stop, I'm going to say speak. I'm going to call speak. Goodbye, have a great day, and get out of this while loop. If query, if there's anything else, I'm going to say response equal to run chain with this query. So I'm going to run this function to process the AI responses and pass the question that user has passed. Next, I'm going to say print AI response is whatever the response that we get back, and speak the response out. This will speak read out the response that comes back. So that's our entire application. As you can see here, this is our entire application. So let's go ahead and talk about it in the next section of what we have done here. We have created the Python script that listens, processes, and responds. So now that we have created our script, we did not test it yet, but let's talk about how the AI assistant works. So what it does is it listens to the user's voice input using a microphone. So as soon as you run that application, it will enable your microphone and start listening to your voice. Next, and it will also specify, as you saw, like we wrote listening dot dot dot. So it will tell the user that is listening to your text. Next, it understands and processes the query using speech recognition. And then it uses Ollama LLM to generate intelligent responses. Then it speaks the response back to the user using text to speech. So it will send the message to Ollama based on what you have sent. It will also send chat history and then give you back the response, which will be converted from text to speech, and it will speak it out to you. And finally, it keeps running until the user says exit or stop. As you saw in the code, if I go back to the code, you see here you are looking for, where is it here? If the user says exit or stop, you just quit out of the application. So that's this entire AI. That's how this entire AI assistant works right now. Running the AI voice assistant. So just to end the climax, what we're going to do is we have already written the code. We already know how this AI assistant works. So let's go ahead and start our voice controlled AI assistant by running Python AI underscore voice underscore assistant, the name of the file .py. So open your terminal or command prompt, and in here, let's make sure we're in the right folder. No, we are not. So I'm going to go inside day 2, clear this out. So now I'm in the right file. I have that file available. I'm going to say Python AI underscore voice assistant.py. This will start running. I've increased the volume.
Hello, I am your AI assistant. How can I help you today?
What is artificial intelligence? It didn't get it right, but let's see what it says.
Artificial intelligence AI refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. These machines can be designed to perform tasks that typically require human intelligence, such as
So it's going to
recognizing
go through the
patterns,
entire thing and
understanding
then
language,
finally ask
solving
me
problems,
again.
making decisions, and learning from experience. AI systems can vary greatly in complexity, from simple rule based systems to highly sophisticated neural networks capable of learning from vast amounts of data. The ultimate goal of AI research is to create intelligent machines that can work and learn autonomously, outperforming humans at nearly every cognitive task.
Who is Elon Musk?
Elon Musk is a South African born American entrepreneur,
It didn't get my question
businessman,
properly, but it was able to still
CEO of
figure out what
SpaceX,
I'm asking,
and founder
and
of
it got me
Dependecies,
this. Now, just to
and
check
CTO of
if
Builiding,
it's keeping
a
memory
founder
or
of
not,
Tesla,
next
and
question I'm
marketing
going to
leader,
ask
among
is
other
what did
roles.
I ask
Elon
earlier?
Musk is known for his work in clean energy solutions, solar power, electric vehicles, and space travel. His companies have significantly impacted these industries with innovations like the Tesla Model S, the first electric car to reach over 200 miles of range, and SpaceX's reusable rockets, lowering the cost of space travel.
What did I ask earlier?
You asked what is artificial intelligence earlier.
Stop. Exit.
Goodbye. Have a great day.
Oh, there you go. So you have your AI assistant responding to your voice commands right here. So I hope you are able to follow along and get this working. Of course, it's not perfect. It doesn't get everything properly, but it was able to reply to my messages perfectly. Again, if you had any problems or questions in implementing this, let me know in the messages and I'll get back to you. So next, let's go ahead and create a web-based AI voice assistant. This time I'm going to create a new file called as AI underscore voice assistant underscore UI.py. How does the web AI voice assistant work? So let's look at it before we even write the code. In this particular case, user clicks the start listening button on the web UI. The AI listens to the user's voice and converts it to text. Next, the AI processes the query using Ollama. AI responds and speaks out the answer, and the chat history is displayed on the UI. So we'll have a better UI this time, which can be presented to someone else or can be added as a project in your portfolio. So let's go ahead and write the code, and after that, we'll run the web based AI voice assistant using the Streamlit app using Streamlit run AI underscore voice assistant underscore UI dot py. So let's go ahead here. I'm going to create a new file here, and most of the code will be similar, but I'm going to just create it anyways. I'll call it AI underscore voice underscore assistant underscore UI.py. So most, as I mentioned, most of the code will be same because the logic is exactly same. So I'm going to go much faster than what I did before, but it will be pretty easy to understand based on what we have done before. So I'm going to start with importing Streamlit as ST. Next, I'm going to import speech recognition as SR, which is similar to what we did here. So rest of the stuff will be same. PYTTS, LangChain community chat message histories. We have LangChain core prompts for prompt template. We have Ollama LLM, which is for creating our AI model. So next, I'm going to go ahead and create our load our AI model by saying LLM equal to Ollama LLM model equal to Mistral. Again, we'll use the same Mistral model. You can change that. Next, gonna go ahead initialize the memory. I'm gonna say chat underscore history, not in st.session state. So instead of going creating this, I'm saying checking the st, which is Streamlit session state. And say st.session state.chat history, chat message history. So if it's not there, I'm gonna create one similar to what we did before. Next, I'm going to say initialize text to speech engine. Here, I'm going to say engine equal to py tts x3.init. Engine set property 160 is the same as this. You've seen probably in the earlier videos that I've done where we didn't set this, the voice was pretty fast, and this is a little bit slower. Next, I'm going to say speech recognition. Recognizer is sr.recognizer. Function to speak AI responses. This will be speak. Engine say engine run and wait. This is much similar to what we did before. Next, I'm going to go ahead and write the function to listen. Say listen with sr.microphone as source. If you see, is the same exact thing. Say st.write listening. Recognize the adjust for ambient noise, so to cancel out the noise. audio equal to recognize the dot listen, start listening. Next, we'll try to recognize the query from users, whatever users said, we're going to create a query and we'll display it out saying st.write whatever user wrote. Again, I say st.write because I'm going to use Streamlit to display it, not the CLI this time. Return query.lower, exception, unknown value error. So I say sorry, I couldn't. Next for sr.request error, where if there's Google service down, so then I'll say speech recognition service unavailable. Next, let's go ahead and define our AI chat prompt. So I'm going to create something similar to what we did, which was the prompt template. I'll say input variables equal to chat history and question, which is again same as what we did before. Create the template, previous conversation, chat history, and then user, question, and whatever AI responses. Next, I'm going to go ahead and write a function to process the AI responses. Here, I'm going to say run chain question retrieve past history. Again, something similar to what we did here. Same thing. Run AI response generation, response equal to LLN, invoke prompt format, chat history is chat history text that we created here, and question is the new question that user asked. Next, I'm going to say store the new user input and AI response in message in the memory. So st dot, we'll use st dot session state chat history and add user message and add AI message. Add them into the chat memory. Next, I'm going to go ahead and return the response. So let's go ahead and design our Streamlit web UI here. So first, for the title, I'll say st.title AI voice assistant web UI. Next, I'm going to say st.write. This will be a small text displayed. Click the button below to speak to your AI assistant. As a button to record voice input. Here, I'm going to say if st.button start listening, user.query listen. So this will start as soon as user presses that button, will start listening and will listen to user's query. If the user query is there, I'll say AI response run chain user query. st.write you whatever you said user query display to the user. Next, whatever user says, I'm going to display that response, and then I'll say speak AI response that came out. Finally, at the bottom, we'll display the full chat history. We'll say st.subheader chat history for for message in st.session state.chat history messages. I'm going to say st.write message.type capitalize the first letter, and the message.content. So that's our entire application here that will run on a web UI. So let's go ahead and run it. If you remember, the code is streamlit run AI underscore voice underscore assistant underscore UI.py. So I'm going to go back here, clear this out, and here I'll say streamlit next run AI underscore voice underscore assistant underscore UI.py. There's two files right now, voice assistant and AI voice assistant underscore UI. When I run this, it's going to open my browser, and there you go, it's running in a URL localhost 8501. But if it doesn't, you can always go ahead and copy this URL to your browser and run it again. I'm going to go ahead and say start listening. Hello, how are you doing today?
I'm just a computer program, so I don't have feelings or emotions, but I'm here and ready to assist you. How can I help you today?
And as you can see, it just gives you an answer and then keeps the chat history below here. You can keep on pressing this button and keep on conversing with this. So I'm going to go ahead and stop there, and I hope you were able to follow along and get through this. If you had any problems or questions with what we have implemented today, let me know in the messages and I'll get back to you. Welcome to day 3 of your hands-on AI agents course. Today we'll be looking at AI-powered web scraper agent. The goal for today is to build an AI-powered web scraper that can search the web for information, extract and summarize key content from websites, store the scraped data for future reference, and work as an autonomous research assistant. By the end of today, you'll have an intelligent AI agent that browses and summarizes websites like a pro. So without further ado, let's jump into our AI powered web scraper agent. Our first step, as always, is to install the required dependencies. Now, before we begin coding, let's look at what all different libraries that we need. For this, we will be installing request, which fetches web page data, We'll be using Beautiful Soup 4, which extracts and cleans text from HTML. We'll be using our usual langchain underscore Ollama, which uses Ollama for AI powered summarization. And we'll be using Streamlit to build a web UI for web scraper. So let's get started. I'm going to go ahead. I will be creating a new folder here. Call it day 3 for our day 3. And that's here. And then again, let's go ahead and install these required dependencies. I'm going to say pip install request beautiful soup for langchain underscore Ollama and Streamlit. So I'll install these, it's going to get installed, and once it's done, I'm going to go ahead and clear it. Again, I can go here and create the file for it, but I'll keep that for later. So once these are installed, you are ready for building our AI web scraper. So let's get started with building the AI web scraper. Let's create a Python script that searches websites, extracts and cleans text, and uses AI to summarize content. So let's go ahead and create our code file. I'm going to go back here. I've already created the day 3 folder. Inside this, I'm going to create a new file. I'll save this as AI underscore web underscore scraper dot py. So that's created. Here, first I'll start with importing the libraries that we have installed recently. So if you have missed the previous days or day 1 and day 2, what I'm going to do is I'm going to still go ahead with the very basic explanation just so that you understand. First, we're going to go ahead and import request, which is used to make HTTP request to fetch web pages. Next, we're going to import Beautiful Soup from BS4, which parses HTML and extracts text from web pages. Next, I'm going to import Streamlit as ST. This is a Python library for building interactive web apps. Next, we are going to import Ollama LLM from langchain underscore Ollama, which is used to interact with an AI language model. Example, Mistral or Llama 3 or DeepSeek, whichever you prefer, you can add it here. For now, I'm going to go ahead and load my AI model, and I'll be using the model Mistral. So this creates an instance of Ollama LLM using the Mistral model. This LLM instance will be used to generate text responses such as summarizing website content in this particular context. You can replace again Mistral with Llama 3, DeepSeek, or any other model that Ollama supports, and that can be used along with Ollama LLM. Next, I'm going to write a function to scrape a website. So this function is called scrape website that takes a URL as input and scrapes its content. Next, I'm going to try and say st.write scraping website URL. This displays a message in the Streamlit UI to inform the user that the website is being scraped. Next, I'm going to create my headers equal to user agent mozilla / 5.0 and response equal to request.get URL headers equal to headers. The headers equal to user agent mozilla 5 sets a user agent header to mimic a real browser request. And then the request.get sends a get request to fetch the web page from that URL that is specified. Next, I'm going to check if response.status code is not equal to 200. If we check if the request was successful, status code 200 means it's successful. If it's not 200, that means something didn't go right. So then I'll say return failed to fetch the URL that was specified. Next, I'm going to extract the text content. So I'm going to go ahead and say soup equal to beautiful soup response.text HTML parser. This parses the HTML content that we got from the web page using Beautiful Soup. Next, I'm going to say paragraphs equal to soup.findAll p tags. What this does is it finds all the p HTML tags or paragraph tags in the web page. Next, I'm going to say text equal to join p dot get text for p in paragraph. So I'm joining all the paragraphs together separated by space. Again, this extracts the text from each paragraph and joins them into a single string. Next, I'm going to go ahead and return text colon 2000. This limits the extracted text to 2000 characters to prevent overloading the AI model. So I'm just creating that. If you want to increase more, you can increase more if you want. Next, I'm going to check for exceptions. I'll say except exception as e, return error string e. If an error occurs, it catches the exception and returns an error message right over here. Next, I'm going to go ahead and write a function to summarize content using AI. Here, I'm going to call the function summarize content and pass the content to it. Again, this defines the function summarize content to generate a summary of the scraped text. Next, here I'm going to say st.write summarizing content. This displays a message summarizing content in the Streamlit UI. Next, I'm going to say return llm.invoke summarize the following content and content colon 1000 limit to 1000 characters. What this does is llm.invoke calls the AI model to summarize the text. The input text is limited to 1000 characters to avoid again overloading the AI. Next, I'm going to say Streamlit Web UI st.title AI powered web scraper st.write enter a website URL below and get a summarized version. Again, this sets the title of the Streamlit app as the AI powered web scraper and displays instructions on how to use the app. Next, I'm going to create the user input. I'll take the user input for the website URL. Here I'll say URL equal to st.text underscore input, enter a website URL. This creates again an input box where the user can enter a website URL. Next, let's go ahead and process user input. I'll say if URL, which checks if the URL has been entered, if the user has entered a proper URL. I'll say content equal to scrape website URL, which calls the scrape website URL function that we wrote here. And then if failed in content or error in content, so if one of these are there in the content that is returned, I'll say st.write that content. Else, so if scraping is successful, it calls the summarize content with content to summarize the extracted text. Next, I'm going to say st.subheader website summary and I'll say st.write summary. So this displays the summary of the web page under the subheader website summary. So there you go. Our entire application is ready right now. So that's all the code that we need to write to create our AI web scraper. So I hope you were able to follow along and get this, and soon we'll be running this in a second. Here, let's talk about, before running the application, how does the AI web scraper work? First, the user enters a website URL. So you want to scrape a website, you have to provide a URL. So let's say you go to Wikipedia or some page or news or web page and get a website URL. The AI will scrape and extract the text from that particular URL. Next, AI generates a summarized version of the page. So it will take that content, summarize it, and then finally results are displayed in our web UI, which is powered by Streamlit UI. So that's the entire process. You just have to find a URL that you want to use and then give it to the website, to the scraper, and AI will do all the work of scraping it, summarizing it, and giving you the result. So let's go ahead in the next video, run our AI web scraper. So let's go ahead and run our AI web scraper that we wrote. To start that AI powered web scraper, we'll have to run this code streamlit run AI web scraper.py. So let's go ahead here. So this was our code. I'm going to go here and make sure I'm in the right folder. Nope, I'm not. So I'm going to say day 3 ls. That's where our file is. I'm going to go ahead and clear it and say streamlit run web, what was the name, AI underscore web scraper.py. It's going to run, open a browser here. As you can see here, it says AI powered web scraper and enter a website based on what we have specified here. It's going to display this right over here. I'm going to kind of add this to here, and then now it's asking me to enter a website URL. So for the website URL, I'll pass the Wikipedia, which is, let me show you this one, wikipedia.org/wiki artificial intelligence. I'm going to take that, paste it here, press enter. It's going to run. It's loading that website, it's scraping the website, getting me the summarized content, and there you go, it got me the summarized content. Our next website that I want to scrape is the bbc.com news technology. So I'm going to go ahead look at it. It opens this website. So go ahead and press enter here. It's running right now. It's getting that content, and there you go. We have the website summary based on what it found on this particular page. This paragraph, these news, historical visual effects of UK, what happens, AI takes. So it will take all these news and give you a summary of all those news articles. So perfect. So we have our application up and running. I hope you were able to follow along and get this working. Our next video, let's try to store this scrape data in a vector database. So now that we have our AI web scraper ready, let's go ahead and store the scraped data in a vector database. So what we'll be doing today in this video is upgrade our web scraper by storing scraped web content in a vector database, which is FAISS. Next, we'll be allowing users to search stored knowledge. Next, we'll be retrieving relevant content using AI. So get started with it. We'll be first installing the required dependencies. We'll modify the AI web scrapers to store data in files where we'll be first scraping the website, we'll be embedding the content, and then we'll be storing it in the files or vector database. We'll enable AI powered search on this stored content at the end of it. So let's get started with implementing this functionality in our code. So I'm going to go here. Instead of updating this application, I'm going to keep this as it is, create a new file, save this as AI underscore web underscore scraper underscore. Since we're going to use FAISS files, I'm going to name it that .py. And then let's get started. First thing that we need to do is we have to make sure that we have installed all our dependencies. For this, I'm going to go here and make sure all our dependencies are installed. Again, we will be also installing the ones that we have already installed in the first one, because if you're directly jumping into the second part into this video, you'll have to make sure that you have request, beautiful soup, langchain Ollama, phase CPU, chroma db, and streamlit available. Again, we have installed most of them before. The only new ones are phase CPU and chroma db. So I'm going to go ahead and run this and make sure that they are available. Go ahead and clear this here. Now, the first CPU that we installed is a local vector database for fast similarity search, whereas ChromaDB is another local vector store alternative. You can use either of them for storing your data in a vector database, which are supported by these two platforms. Again, fast CPU or ChromaDB. So I'm going to go ahead here and start with our imports. We start with importing request, which again makes HTTP request to fetch web pages. We need beautiful soup, same as before. Streamlit, we need files. This is the new thing that we've added, where this is a Facebook AI library used to efficiently do similarity search. That's what pretty much it stands for, like Facebook AI similarity search. Next, we're going to import NumPy as NP. Next, we're going to import Ollama from Ollama LLM, and then we're going to get the Hugging Face embeddings. Now this is an updated import. This used to be a little different from the previous version. So if you have the previous version getting directly from LangChain, it's from LangChain Hugging Face now. Next, I'm going to go ahead and import files langchain underscore community vector stores. Next, I'm going to get character text splitter from langchain docs text or splitter. This one, the files, this is a files based vector store used for storing and retrieving embeddings. This is the AI that is used for similarity search, whereas this files is actually the vector store used. And then again, this character text splitting splits long text into smaller chunks. We'll be using that for storing data. And then I'm also going to import document from langchain.schema, which represents structured document for processing. Now let's go ahead and load the AI model, which is same as before. I'm going to not go over some of these that we did in the previous video. If you skipped the previous video, I would recommend you go there and check that out. So Ollama LLM model is Mistral. Next, I'm going to load the Hugging Page embeddings. Here, this is the updated version. Again, if you have seen my previous videos, these are the most recent one as of March 2025, where I'm saying embeddings equal to Hugging Face embeddings, model name equal to sentence transformer, all mini LM L6 V2. This loads a sentence transformer model, which is all dash mini LM dash L6 dot V2. This is used to convert text into numerical embeddings for similarity search, and that's what we need in a vector database. Next, I'm going to go ahead and initialize a files vector store, where I'm saying index equal to files dot index flat L2 384, the vector dimension for mini LM. vector store is empty. So what this does is the first line face index flat L2 384 creates a face index for similarity search. The L2 distance, which is the Euclidean distance, is used for measuring similarity. The 384 number is the vector size matching the mini LM embedding model. The vector store that we're creating here is a dictionary to store the website URLs and their text chunks. So let's go ahead and start to write a function to scrape a website. Again, we wrote this before, where we say scrape website URL, try st.write scraping website, headers user agent Mozilla 5.0, responses request.get headers, response status not equal to 200. This is exactly same as what we wrote here, just FYI. Let's say fail to fetch. Next, I'm going to say extract the text content. Beautiful. Soup, get the response text. I'm going to use the HTML parser. Paragraphs, soup, find all P. Then I'm going to join all those paragraphs together into a single string and return that text. This time, I'm going to use 5,000 characters to avoid excessive processing. Next, I'm going to go ahead and look at the exceptions. If there's an exception, I'm going to say return error and then pass the exception that occurred here. Next, let's go ahead and write the function to store data in files. Let's move it up here. I'm going to say create the function store in files, pass the text and URL here. This stores the scraped text in files vector database here. Next, I'm going to say global index and vector store. This declares index and vector store as global variables to modify them outside this function too. Next, I'm going to go ahead and say display a message in Streamlit by saying st.write storing data in files. Next, I'm going to split the text into chunks. Here, I'm going to say splitter equal to character text splitter, chunk size 500, chunk overlap 100. This splits text into chunks of 500 characters with 100 characters overlap. Next, I'm going to say text equal to splitter dot split text. So this completely splits text into chunks of 500 characters based on this. Next, I'm going to say convert text into embeddings. For this, I'm going to say vectors equal to embeddings dot embed document text and vector equal to np dot array vectors comma d type equal to np dot float 32. What this does is this converts text chunks into embeddings using the Hugging Face model, and then converts embeddings into numpy array of float 32 format, and that's why the d type np dot float 32. Next, I'm going to store this in files by saying index dot add vectors. I'll say vector store length of vector store equal to URL text. What this will do is this will store embeddings in files. It stores the URL and text chunks into the vector store. And then finally, I'll say return data stored successfully. So that's a success message. Next, let's go ahead and write a function to retrieve relevant chunks and their questions. So for this, I'm going to say def retrieve and answer query. This defines a function to retrieve relevant text chunks from files. I'm going to say global index vector store. Again, these I'm declaring them as global. Convert query into embeddings by saying query vector equal to np.array embeddings.embed query d type equal to np float reshape 1 comma minus 1. What this does is it converts the user's query that he passes into an embedding right over here of float 32 type and reshape that to 1 comma minus 1 vector. Next, I'm going to go ahead and search the files. Here, I'm going to say d comma I equal to index search query vector k equal to 2. Retrieves two similar chunks. So this searches for the two top most relevant text chunks. Next, I'm going to say context equal to empty and then say for index in I of 0, I'll say if idx in vector store, then context plus equal to space join the vector store index at 1 and then put two next line characters. So this retrieves the text chunks that matches the query and attaches here. Next, if not context, if there's no context, I'll say return no relevant data found. Now, so in this case, if no relevant data is found, it returns this message. Now let's go ahead and ask AI to generate an answer. So that I can say return LLM dot invoke based on the following context, answer the question, and I'll pass the context that we have here if there is a context, and question will be the query that is passed here. So that will go ahead and retrieve data from the FIRES database and return it back to whoever called it. Next, let's go ahead and create our Streamlit Web UI. And give a title, AI powered web scraper with file storage, and give a text instruction here saying enter a website URL below and store its knowledge for AI based Q&A. Next, I'm going to say user input for website URL equal to st.text input. So this will be the text input where I'll say enter the website URL. Now, if the user enters a URL, I'll say content equal to scrape website URL. This creates a text input box where the user enters a website URL and it calls the scrape website URL to extract content. Now again, if there's failed or error, if any of these fails or errors here while scraping the website, I'm going to say st.write. I'll just give the message failed or error based on what we get here. Next, I'm going to say else store message, store in files, content URL. If it's successful, I'll store the message and then st.write display the message to the user right over here. Next, let's go ahead and get the user input for Q&A. So here I'm going to say query equal to st.text input. Ask a question based on stored content. If query answer retrieve and answer query. So this will call this function where we are retrieving an answer based on the query that user has entered. Next, I'm going to say st.subheader AI answer st.write whatever the answer that we retrieved. I'm going to display it to the user. So that's pretty much the entire application, which now not only scrapes the website but also stores it locally and then gives you an option to ask question based on the stored content. So let's go ahead. I'm going to take this application. Next step is to run the application. Go here and run the same command streamlit run AI web scraper underscore FAISS.py. This will run. It says file does not exist. Let me see which folder I'm on. I am in the right folder. Let's see, I spelled scraper wrong, so I'm gonna spell it wrong here too. Run it, and it's running. If it's not running, just open this and open it in the browser. So for me, it opened up the browser and it's running right now. If it doesn't, just take that URL and then run it in the browser. Again, the website URL, I can give the BBC URL or I can give my Wikipedia URL. So I'll put that Wikipedia URL here, press enter. It's going to store it, storing data in files because it was successfully able to get that data. I'm going to move it a little bit up. I say data stored successfully. Ask a question based on the stored content. I'll say, what is AI? Enter. It's going to go and fetch data from that stored vector database and find me two similar answers because that's what we mentioned here. Get me the top two answers. And there you go. It gave me artificial intelligence is a field, whatever, and gave me the answer based on what it fetched from that data store that we saved based on here. So if I also try to search these things, probably I'll find it in this Wikipedia URL here. So I hope you were able to follow along and get this working for both building a simple AI web scraper with a UI and then building and storing it inside a vector database. If you had any issues or questions based on what we completed here, let me know in the messages and I'll get back to you.